What if the Earth were shaped like a donut? Now, before you reach for a jelly-filled snack, let's be clear, we're talking about a torus, a perfect planetary donut with a giant hole right through its center. It's a ridiculous scenario, of course, but as a seasoned physicist and part-time cosmologist, I'm professionally obligated to consider it. The first thing you'd notice, besides the sheer geometric oddity, would be the gravity. On our current spherical Earth, gravity pulls everything toward the center. On a donut Earth, things get a little weird. For one, gravity would be strongest along the inner and outer equators and weakest at the poles. But the real mind bender would be inside the hole. Gravity would be pulling in from all sides, creating a kind of null zone right in the middle. If you were to free fall through the hole, you'd slow down as you neared the center and then accelerate out the other side. This would be a great way to travel, assuming you could survive the trip. But let's be realistic here. A torus-shaped Earth would have some serious problems. A spherical planet is stable. It's the most energy-efficient shape for a rotating mass. A donut planet would be incredibly unstable. It would likely wobble uncontrollably, and any small perturbation, like a large meteor strike or a particularly strong earthquake, could send it tumbling through space like a cosmic frisbee. The centrifugal force from our daily rotation would also be a nightmare. Anyone living on the outer edge would experience a powerful outward pull, possibly strong enough to make them feel lighter, or even to launch them into space. People on the inner edge would feel an inward tug, making them feel heavier. Then there's the whole sunlight issue. On a spherical Earth, every part of the globe gets a turn in the sun. On a donut Earth, the inner ring would be a permanent twilight zone, shrouded in the shadows of the outer ring. This would create a dramatically different climate on the inside and the outside. The inner ring would be perpetually cool and dim, a land of eternal twilight. The outer ring would have normal days and nights, but the seasons would be extreme, with wildly different angles of solar radiation depending on where you were. It would also lead to some bizarre weather patterns. The temperature differences between the perpetually shaded inner ring and the sun-drenched outer ring would generate massive planet-spanning storms. We're talking about tornadoes the size of continents and hurricanes that would make Jupiter's Great Red Spot look like a gentle breeze. And what about our oceans? The water would pool at the weakest points of gravity, at the poles and in the ring's interior. You'd have massive, swirling vortexes of water and a world with two separate oceans. The entire planet would be a chaotic swirl of water and land, with no clear distinction between continents and seas. No wonder we've never found a donut-shaped planet. The very physics that holds a planet together would conspire against such a shape. So while the idea of a donut Earth is a fun thought experiment, the reality would be a world of gravitational chaos, extreme weather, and two separate oceans, a place so unstable it would likely tear itself apart before it could even support life. So, for now, I'm sticking with the boring old sphere. It may not look as interesting, but it's a lot less likely to send me tumbling into the abyss. Though, I must admit, the idea of a permanent twilight zone is rather tempting. But wait, what about the hole? Is it possible to build a space station inside the donut's central null zone, a perfect zero-gravity hub for all of humanity? And would the universe, in its infinite irony, taste like sprinkles?